So solution dilution is one of my favorite things to say all semester. Solution dilution is going to be using what we talked about, how the number of moles is equal to molarity times volume. So whether you saw it in the triangle or with my dimensional analysis, that's really what we're talking about here. So if I have one solution and I'm going to mix more water into it and dilute it, I'm not changing the number of moles. And so the moles before and the moles after should be the same. So that's what we're talking about. When you dilute a more concentrated solution, and sometimes a standard solution, like that I could buy from the supply company. So the concentration of hydrochloric acid from the supply company is 12 molar. And so I don't want to make 12 molar. It's going to burn my skin. And so I can dilute that into, say, 1 molar solution, but I have to know how to do that. And so we use solution dilutions, or an equation, to help guide us into calculating how I can make a new solution from another solution by diluting it. And so the trick of it, like I say, is that the number of moles before is equal to the number of moles after. And so here we have the initial concentration and the initial volume equaling that secondary concentration and that secondary volume. You're going to have the higher concentration and a lower volume, and then a lower concentration and a higher volume as you dilute this concentration, or this solution, so dilution. The volumes can either be in milliliters or liters, so long as they are in the same units. Now, I find this to be a bit of a pitfall, because when you are using that triangle, you had to put them into liters. So if you think that this is something that you would be vulnerable in making mistakes around, then always convert your volumes into liters. I'm going to start by converting them all into liters to make a point. But it is a bit of a shortcut. So it's the safest bet to put them into liters, but there is this little bit of an asterisk here. So here we have our first example. Calculate the new concentration. So anytime you see stock solution or original concentration, it's probably one of these that uses this equation. Calculate the new concentration, so that would be an M2, of a sulfuric acid solution prepared by diluting 5 mils of this concentration. So that is an initial volume and an initial concentration, with enough ionized water to make this as my secondary volume. So I like scribbling in a question to kind of sort out what I have. I also like brainstorming or gathering my information down the side. So in this case, it says calculate the new concentration. That is going to be my question mark. When I have a V1, 5.00 milliliters. And like I said, to be safe, you can always put that into liters. And a concentration of 2.00 moles per liter, or a molar solution of 2.00. And I have 100 milliliters after. And again, I want these to match. Safe bet is to put them into liters. So that's what I'm going to do for this question. The equation that we're dealing with is that these two should equal each other. We haven't changed the number of moles of my sulfuric acid present. So if I have this as my equation, I can just sub into it to solve for what I'm looking for. M2, and then my volume 2. So if I want my M2 all by itself, I'm dividing by that, and I have to divide on both sides. So that's gone, and I've now solved for M2. So I would just put this in my calculator, top times the top and divided by the bottom. My secondary concentration, or the concentration of my sulfuric acid, oops, is, in this case, look at the right place, 0.100 moles per liter. after all that dimensional analysis, kind of that plug in and solve, it's sort of refreshing. Sometimes it's hardest to figure out all these variables and what's represented by what number. So this one says what volume of, so we're looking for a volume of this molarity, sodium chloride, NaCl, in case I need it, is required to make, so this is my 2, my volume 2, and my molarity 2. If you screw up the 1s and the 2s, it won't matter. So long as you know that these ones go together and these ones go together, those subscripts don't matter at all. So I'm going to start over here. I'm going to call these my 1s. So M1 is 1.25 moles per liter. My V1 is what I'm looking for. We want to make an M2 of 0.500 molar concentration and a V2 of 50.0 milliliters. So in this one, I can switch that to liters. And again, if you want to, you can. It makes for big awkward numbers, but it's definitely a safe bet, especially if you're going to use a molarity triangle or do some dimensional analysis in another step. But with this one, what we're looking for is the missing before and after situation. Whoops, not 2 there. M1 V1 equaling M2 V2. And I like kind of listing them all out because it keeps me organized in my thoughts. So subbing in, I could solve by dividing by 1.25 on both sides. And my calculator will tell me that my V1, or my volume of sodium chloride, is, in liters, really awkwardly, 0.0200 liters. Now, this is given it in milliliters, and honestly, as long as you put in milliliters, milliliters will come out, right? So if this is, you're like, oh, forget it, I'm not going to bother converting to liters, totally fine. This is correct, or 20.0 milliliters is also correct. Absolutely fine. And again, why I've converted to liters is that sometimes you're allowed to keep it in milliliters, but not always. And so that pitfall can be problematic when you're learning this stuff. Okay, so the next one. I'm done converting it to liters because I find it a little bit cumbersome. So let's do this one in milliliters. So it says calculate the concentration. So I'm looking for a concentration of hydrochloric acid solution made by diluting a V1 and an M1 with 100 mils of deionized water. So sometimes with these, it takes a little bit of reading and a little bit of organizing because there's something else going on with this. So my V1 is this 10, or sorry, I should do this in order. M1 is 1.00 molar. My V1 is 10.0 milliliters. I'm going to take my advice this time and leave it in milliliters. Okay. My M2 is what I'm looking for, and my V2. What's going on is you're taking that 10 mils of solution and you're putting 100 milliliters of water in it. So my V2 is that 10 mils plus my 100 mils, right? My V2 is 110 milliliters. And so that takes a little bit of thinking as you read through this question. So my equation is M1 V1 equaling M2 V2. I'm simply going to sub in what I have here. M2 and 110.0. Divide both sides by 110. That's going to calculate the secondary concentration of this hydrochloric acid solution. And that works out to, rounding to 3 sig fig, 0.0909 moles per liter. So in that one, because I left this in milliliters and this in milliliters, that's what made it okay to not switch it into liters. So we've got a few more to do here based on this idea. Now this one has a bit of bolded information, Back when we talked about molarity, we talked about ion concentration. So this question says, what is the ion concentration in a solution made by diluting a volume of a concentration with 100 mils of water? So this one's kind of like what we just did. Now the compound that we're using is ammonium chloride. So let's start with that. Sorry, aluminum chloride, not ammonium chloride. Ammonium chloride would be easier. So aluminum chloride, aluminum is a +3 combining capacity. So the formula or for the compound is AlCl3. Now, if we think about how this dissociates and the fact that this question is not asking about the concentration of aluminum chloride, but specifically the chloride ion, we're going to take what we are starting with, which is a 0.5 molar concentration here, and use that skill that we had before. So we have the aluminum, 3+ ion, and 3 chloride ions. I left the AQs off here. Sorry, I probably should have put them in. So this is a 1-to-1 ratio, but for every mole per liter of aluminum chloride, that's going to give us 3 moles per liter of the chloride ion. So 1.50 moles per liter of the chloride ion. So what I'm going to do is use this, right? This is my chloride ion concentration initially. So my M1 is 1.50 moles per liter. My V1 is that initial, right? Sorry, I got distracted in my thoughts. And my M2 is what we're looking for. So calculate the concentration, right? My V2 is this 5 mils plus the 100 mils. Whoops. So 105 mils. So now that we have done a little bit of extra work, these ones are tricky, right? We can calculate what I'm looking for. I'll keep going and then I'll give you a bit of a disclaimer on this one. This one's definitely easier if I leave it in milliliters. I guess they all are. I divide by 105 on both sides. If you don't need to show this step, that's okay. So my secondary concentration, my concentration of chloride ion, because that's specifically what I'm talking about here, is 0.0714 moles per liter. That's an M. So in this one, I've done this 2 different ways. I like doing it right off the bat, but you can also kind of calculate the concentration without multiplying it by 3 and then multiply it by 3 at the end. So there are a couple different ways to get to the right answer. This last one is much like that one. So if you want to pause the video and give it a try, that might be a good idea. I'm going to do it just a little bit, I'll explain it all out. So this one says how much stock solution, so that's the concentrated stuff, and water are needed to make 50 mils, so that's a V2 solution with a hydroxide ion concentration of 0.105 molar. If you start with 1 molar barium hydroxide. So in this is what's going to give me my M1. But barium hydroxide, if it's in solution and it ionizes, I would have barium ions in solution. This time I remembered the states, and hydroxide ions in solution. And so what we're starting with is 1.00 molar. Now this ion mole to mole ratios allows me to see the concentration of the hydroxide ion initially, which is twice what the barium hydroxide concentration was because of how it dissociates in that mole to mole ratio. So my M1 is there. My V1 is what I'm looking for, right? How much stock solution, right? So that'd be my V1, and water, but I'll get back to that one, to make 0.150 molar, right? That's what we're trying to make. And we have a certain amount that we need, which is 50 milliliters. Okay, so this is going to be my stock solution, right? That I'm going to concentrate. Anytime I make these solutions, though, it's the stock solution and water to make this. So there's kind of two steps in answering this question, and there's a number of these in the textbook. So my M1V1 equaling M2V2. If you've sorted out all your information, this isn't the hardest part. So I'd have 2 molar and V1, which is what I'm looking for, and my 0.150 and 50 mils. So my V1 ends up being 3.75 milliliters. Now that is the stock solution. To make my solution, my V2, this is water and my stock solution. So if I need to figure out how much water, I could take 50 minus the stock solution, and that gives me my 46.3 mils of water. So a little bit of extra work at the end and a little bit of understanding what's actually going on in the concept of dilution. So, you know, this wacky system of sorting your information, taking your time, can really be key, because when you get down to it, the math isn't actually that hard, but the setup can be, and understanding the chemistry and the words is a bit of a trick of it all.